Hey guys, this is the regressions lesson for chapter 4. So you are given this table, and then remember to run a regression, we're going to use decimals. So I already have this all graphed and everything. So what we're going to do, remember to get this table in there, we just hit this plus, and then you go table, and then enter in all of your data. Then it tells us that we need to run linear, quadratic, cubic, and quartic regressions. So remember to run a linear regression. That's what I have graphed here. We're going to enter this equation, y1, and then you have that tilde, mx1 plus b. Those ones are super important, otherwise your line won't graph. And then they want us to give the linear regression equation. So here is the basic equation, but then they give us the m and the b values. So those we need to use. Okay, so I'm going to go back to our worksheet here. And the linear regression was y equals, our m value was, we can just round here to the second place value, 0.55x plus 52.79. And that I got, remember, just from looking at M and B. Then they tell us to look at the correlation coefficient. And for these, since we're comparing, we want to be comparing the same value for all of them, and all of them have the r squared. They don't all have the r, so that's why we're going to look at the r squared values for this correlation coefficient. And this one here we see is 0.82 if we round, so I'm going to put that in here. And then we're going to go ahead and do that for quadratic, cubic, and quartic as well. And for those, you're just going to enter the standard form equation like we would. Here is the quadratic, ax squared plus bx plus c. And then for the cubic and quartic, we're just simply adding on an extra term, right? So our first term is going to be cubed, and then the power goes down by 1 every term. And then for quartic, we start with to the fourth, and it goes down by 1 every term. So then we just need to, once we get those in, remember the y1 tilde x1. And then we need to look at our value. So I'm going to go ahead and take off the linear and turn on the quadratic. Okay, and then we can see how that looks with our data points. And again, now we're looking at the A, B, and C values here. I'll just highlight those here. A will be 0.007, we'll see 0.008. B is 0.17, and C is 56.63. So I'm going to go ahead and write those in here. So for our quadratic, we have y equals
Attention faculty and staff,
0.008.
Please know that we tested the alarms this morning and been unable to reset the northwest corner or section of second floor. Again, there is no actual fire alarm right now or danger. You are safe to be in the building. We are having issues with our electrical system. Specifically, we cannot get the northwest section of second floor to reset. So that affects world language, some English classrooms, and a few science classrooms. We're working on this right now. We apologize for the inconvenience and the annoyance. Thank you.
Hey guys, sorry about that announcement. There's fire alarms going off upstairs right now and they can't get them turned off. But we have the next thing we need to do is look at I forgot to do this actually, the correlation coefficient, which remember that r squared value is that, so it's 0.83. And then we're going to go ahead and fill that in. Oh, I already did. Okay, so next is cubic. And here we see A equals negative 0.001, B 0.089, C negative 0.158, and D is 66.7. We'll do 0.80. And then our correlation coefficient is 0.87. So go ahead, fill in all of those values as well. Remember, this is cubic, right? Because it's third degree. And then my correlation coefficient was 0.87. And then finally, we're going to do our quartic, which is, remember, fourth degree. Okay, so again, we're looking at A, B, C, and D, but on this one, notice we need an E and they don't give us that. Remember, our E is going to be our y-intercept. So what I'm going to do to get that, if I click on the graph here, they actually give it to us. So we can see that's 2.72. I'm not sure why they don't give us the E, list the E value here, but another way to find that is look at the y-intercept of the graph, right? Okay, so I'm going to take all of these values, plug them into my equation. And then, as well as the correlation coefficient. So I had y equals negative 0.0002x to the fourth plus 0.02x cubed minus 0.86x squared plus 12.09x plus 2.72 was that y-intercept. And then my correlation coefficient was 0.5. Okay, so which model best represents the data given? So we determine that by, so we're gonna be here. We determine that by our correlation coefficient. So which one has the highest correlation coefficient? Well, that would be the cubic, right? So remember, a strong correlation coefficient is going to be closest to 1, and then weak is going to be 0, right? So it could be 1 or negative 1. We can have negative there. That would be fine as well. That just means it's a negative function. Okay, so anyways, closest to 1 here, 0.87. So then that was the cubic. If you had not studied at all, which model best represents the test score? So I'm going to go actually back to Desmos and turn all of these on. And they're saying if you studied 0 hours, which is best going to represent that? Well, here, if we're looking, like, does it make sense that if we study 1 hour, we're going to be lower than if we study 0 hours? Like, right, the y-axis would be studying 0 hours, but then as we move right, we're going to be, like, we would expect a higher test score for studying more, right? So this red one, which is our cubic, it's not going to be that. And then we see